And we're live. Great. All right, let's just finish getting YouTube set up. Think my audio's probably okay. Pop out some chat. All right, why can't I see the... Why can't I see super chats anymore? Weird. Oh, okay. All right, anyway, why can't I see super chats? It only shows probably okay. It only shows... That's so strange. It only shows top chats and live messages, live chats. Okay, well, that's fine. Right, let's get to answering some questions. So can you explain scattering? So scattering is just, it's kind of like a general phenomenon of basically you have two things that are separate, they come in, do something, and then they go out. And so when we're talking about scattering, what we're talking about is we're talking about the relationship between the input data and the output data. So like a really trivial example of scattering would be like, you have a baseball, you chuck a you have a baseball and a basketball. They come in, they bounce off of each other, and they go out. What angle do they come out at, and how does that depend on the angle that they go in at? And speeds and things like this. Sorry, I'm going to close my door really quick. No, you're fine. And so that would be an example of scattering. But more specifically, we use like scattering to study quantum field theory and the like, which is significantly more complicated, perhaps. But it is still the same. Anyway, if you guys are just joining us, make sure to like the live, subscribe, follow, consider joining the Discord. There's a link in the description on YouTube. There's a link in my bio on TikTok. Join the Discord, ask some questions there, although I will answer only live questions here today. These are all good things to do, so feel free to ask your questions and I will get started. I just got the notification. How long has this been playing? We just started. Would I be upside down? If you were upside down, I suppose. What was your thesis on? My thesis was on conformal geometry and hypersurfaces. Is that a water bear? It is. Can you use quantum mechanics to learn telekinesis? You cannot. How does multiphoton absorption work? Multiphoton absorption is going to be a really complicated process, or a really rare process, where essentially you have a multi-vertex interaction happening between, say, an electron and two photons or more. Two or more photons in, a complicated interaction that might have one or more loops, right? Does entropy point to a finite universe? Not necessarily, no. Why aren't electrons pulled into the nucleus? Right, because in some sense they're orbiting, right? They have too much kinetic energy to fall in, because to fall in would mean that they would have to slow down and then get to the bottom. If I hadn't seen you being such a condescending jerk so many times, I might watch. But well, okay. Well, if that's how you feel about me, who am I to tell you otherwise? They don't quite orbit. They exist in orbitals, and the orbits aren't like a single particle moving around, right? What do you think about Lily Tino? I know nothing about her. Have I read Dune? I have not. I've just learned learned of a field called astrobiology. It seems weird. What do you think? It's a real field. Somehow we need to study extraterrestrial, or we need to study what would be required to, have life elsewhere in the universe, and so that's a useful thing to talk about. What's the difference between particle and molecular physics? Molecular physics has to do with molecules, which is like compounds made of atoms, and particle physics has to do with subatomic particles. Have you done any work in aerospace? I have not. Why do planets orbit in the lateral plane but not vertical? So most planets orbit this way. I mean, depends on how you're doing it, but if the sun's here and your planets will all orbit this way. And the reason for that is essentially conservation of angular momentum. You'll find that anytime you have a whole bunch of stuff orbiting in a whole bunch of different directions. Oh, that's weird. That just happened. Sorry, one sec. Let me just fix that. There we go. Anytime you have a whole bunch of different particles orbiting in a whole bunch of different directions, eventually they will collide and their velocities will equalize, so they're all traveling in roughly the same direction. But that's essentially due to conservation of angular momentum. Tell me about how the nonlinearity of empty space results in matter condensation at certain you have to be more specific. Which matter condensation? What's the difference between applied physics and engineering, especially on their intersecting fields where their lines can be blurry? Well, it's blurry. That's it. Can you explain what Lagrangian is and why it matters that they're absent from Eric Weinstein's grand GU? So a Lagrangian is a mathematical object that in some sense is kind of like the fundamental way that we characterize quantum fields. And even more so, the way that we do physics nowadays is using a Lagrangian. So you write down a Lagrangian, and that Lagrangian basically tells you everything about the quantum physics, or about the physics that you want. You can use Lagrangians to study classical physics, quantum field theory, anything that you want. And so if you have a theory and it doesn't have a Lagrangian, you have some serious explaining to do. Can you explain why time slows down near a black hole and explain it to me like I'm 5? Look, so near a black hole, space and time both change. The way that they behave changes because space and time is bending. So space bends into time and or vice versa. And so what this means is that just as a result of this warping of space-time, an object near the event horizon will experience 5 minutes, whereas an object far away might experience 5 days. Son of Gore with the $2. Could scientists create a black hole on Earth? Not with current technology. It would require far, far more energy than we have access to make a black hole. Is it logically possible that time could have an end? I suppose, yeah, sure. Have you ever considered a career in finance, or any colleagues you know who've made the switch? I don't know anybody offhand who has, but I know it's fairly common, but I have not. Wouldn't we have reached maximum entropy if the universe was infinite? Not necessarily. What is dark matter? Dark matter is the hypothesized thing that has mass that doesn't interact via electromagnetism, meaning we can't see it, but it still has mass, and so it would still have a gravitational effect. And it is the hypothesized thing that is causing, that has mass, that is causing the observed gravitational effects that we see that don't correspond to stuff that we can see with light. Have you I already answered that. What are your thoughts on matter-antimatter asymmetry? I don't have a lot of thoughts on it. I know that there's a thing called the Sphaleron process, which can induce matter-antimatter asymmetry, but my understanding is that that process is sufficiently rare that we don't expect it to account for the difference that we actually see in the real world. Show us one experiment where gravity is the independent variable. Boom, no gravity, no globe. I mean, the Cavendish experiments do that. I mean, the independent variable there is like the distance, and then the dependent variable is the force, and then the distance has a relationship with the force. And so you get that there is a force law that relates mass, distance, and force. Anyway, if virtual photons don't exist, then what actually mediates the EM interaction? The electromagnetic field does. I'm a little bit behind. I have to jump to the front. Sorry. By the way, if you like what you're seeing, if you like me doing these lives, a good way to do it is to support me to do them. I'm more encouraged to do them when full honesty, completely open book here. Typically, debate lives are more lucrative. People send more donations because it's more bloodthirsty, if you will. But I value doing these lives because, you know, education is part of the thing I care about doing. So supporting these lives encourages me to do them more often and longer. So if you like that, that's how to do it. If you don't like it, if you'd prefer me to do debate lives, then go support those ones and don't support these ones, right? Something, vote with your wallet. How do you calculate superposition? It's not really a thing you calculate. It's more of just like a property of a thing, right? So you can have if you have, you could say that like northeast is in a superposition of north and east. Like that direction. Dark matter is matter that's dark. Yeah, well, roughly, yeah, basically. Do you think the universe is discrete or continuous? I kind of flip-flop on it, to be honest. Like, if I'm just being honest, like, I don't have a well-founded position on it. Asking how matter condenses from energy, I should be more specific. That in itself is interesting. Well, what matter are you talking about? Matter doesn't just, like, pop out. Energy is not a substance that condenses. It's more that, like, fields can have different energy content. Can you talk about Noether's theorem? I know how it works in Lagrangian mechanics, but I was told it's more general. Noether's theorem is a statement about Lagrangians. Now you can do like Lagrangians of like classical fields. You can do Lagrangians for like quantum fields, and it will be, you know, more and more complicated, but it's always about Lagrangians. Why are wormholes so sensitive to collapse? Essentially, they're like unstable equilibria. That's the idea. If you have an unstable equilibrium and you perturb it just a little bit, it'll fall apart. How does the weak force work? So the weak force is a manifestation of W's and Z bosons and their virtual counterparts doing stuff. The W and Z fields, I should say. And essentially what happens is, from the weak interaction, the interaction with the W's and Z's, you have a vertex with three things coming in or out. So you can have an electron, a neutrino, and a W, or you can have an electron, a muon, and a Z, or you can have a quark, a W, and another quark, or a quark and a Z and a quark. And so the basic... Oh, we got a Cash App. Grimlock, thank you for the $10. How much have you hydrated today? None yet, so thank you for the reminder. So the weak force is basically a kind of, rather than being a force that causes a thing to be like bumped, like if you think of an electron interacting with a photon and then another electron coming out, that electron was basically just kicked by the photon coming out. But the weak force doesn't do that. The weak force is like a transmutation force. If gravity bends light and light is how we observe everything, how do we know our perception is true? Well, we can see we can see things that are causing the bending of light. That's the whole point. Like generally, light bends around things that we can see, and we can figure out then that it's the things that we see that causes the light to bend. Like we can see the light bending around the sun ever so slightly, and so we know what the thing is that's causing the light to bend. So we know where it would be if the sun wasn't there. Sorry, my green screen's shining through. There we go. Just had to fix that really quick. Is it true in physics that matter could be changed to gold by a device called the accelerator? Yeah, it's just really expensive and not efficient. Could you explain the difference between time and space-time? So time is just a piece of space-time, that's all. Think of it as like a schoolhouse. A schoolhouse is part school, part house. Sort of. How do I achieve quantum tunneling? For yourself, you don't. It won't work. How to get into physics, where to start, maybe some source recommendations. Yeah, the same book I recommend every single time people ask this question. A Brief History of Time by Stephen Hawking. It's a little outdated, but it is a spectacular book. When can you debate flat earthers? Probably once a week. Can you explain the wave-particle duality? Been trying to wrap my head around it for years. So there really isn't a wave-particle duality. There are waves, and sometimes those waves are localized, meaning that like you have a wave and then nothing. So it sort of acts like a chunk of stuff. It's like a particle, but it's always still a wave. That's kind of the observation that we come to. That's the conclusion we come to from quantum mechanics. How are contact manifolds different from general Riemannian manifolds? So contact manifolds don't have a metric in general, and Riemannian manifolds do. How far you've gotten with the theory of everything? That I don't work on that. Isn't the point of QFT that interactions are mediated by particles? So saying virtual particles do not exist goes against QFT? No. QFT is not that interactions are mediated by particles. QFT is that interactions are mediated by fields. That's what the F in QFT stands for, right? Quantum field theory. It's excitations of the fields that are particles. How's gravity both the weakest force in the universe and yet the only thing strong enough to overcome the speed of light limitation? Gravity doesn't overcome the speed of light limitation. Gravitational waves travel at the speed of light. How fair is your mathematics? What do you still struggle with? Generally, like anything that's like sophisticated algebraic geometry stuff, like I don't understand that very well. I tried to, but can you explain wave function collapse? Yeah, so the idea behind wave function collapse, which by the way has never been observed, just so you know, we've never observed wave function collapse happening, The idea is that when you make a measurement, for some reasons that we don't really have an explanation for, when you make a measurement, when you interact with something, that causes a quantum state that exists in a superposition to instead pick one of the pieces of the superposition and collapse into that, and the other pieces just disappear. Any book for dumb beginners just to get started? A Brief History of Time is readable. Can you explain why stars cannot fuse heavier elements than iron? Yeah, so this is a great question. So, oh, from Ethan with the $10. Thank you for the 2 coffees that you've bought me, Ethan. I appreciate you. I don't know if that has a question attached, but let me double check. Because I have to make sure to answer questions. Dad didn't come to my piano recital where I defended many worlds. I'm so sorry. Alan Rouse with I'll answer the iron question in a minute. Alan Rouse with the 3 Australian bucks. What do you think of string theory? I think it's brilliant. I think it's a brilliant theory. I don't think it applies to our universe. Maybe that answers your question. Right. So the question was about why stars stop forming elements of iron. And roughly the idea is that there are two different forces that are kind of fighting each other when you're talking about an atomic nucleus. On the one hand, you have the strong nuclear force trying to pull nuclei together. So you have protons and neutrons that are grabbing at each other and trying to hold each other together really tightly. However, the strong nuclear force is very short-ranged. And what that means is that when the nucleus gets sufficiently big, that strong nuclear force gets very, very small very, very quickly. On the other hand, you have the electrostatic repulsion. So you have protons, which are all positively charged. They're trying to push each other apart. And so when you have only a few protons and neutrons, the nucleus is small enough that the strong nuclear force can hold it together really tightly. And so if you add more protons and neutrons, that releases energy because those protons and neutrons want to be in the nucleus. On the other hand, when your nuclei gets big enough, now the nucleus wants to fly apart. And so it releases energy by giving off protons and neutrons, or by splitting. It releases energy that way. So adding protons and neutrons up to a certain level will output energy, and then subtracting protons and neutrons after a certain level will output energy. So there's some middle point where the input and output, or where adding and subtracting protons and neutrons doesn't change the energy at all, and that's exactly at iron. So basically, if you're trying to fuse atoms together, which is what happens in the core of a star, those atoms are getting squeezed together and it releases energy up until the point where they get to iron, and then it no longer releases energy when you squeeze atoms together. And so they just collapse at that point because there's nothing keeping the star up. The energy that was being released doesn't exist anymore. Is it practical to consider doing physics as a hobby while doing a 9-to-5 for the money? Not so practical. I mean, if you have the education, then you can potentially still involve yourself in research, but it's not so practical. Why can't someone develop a camera that doesn't melt easily and press it in the ocean? I don't understand the question. If burst of energy used to propel a spacecraft while already in space, how long does the momentum last? Momentum lasts forever. Momentum is conserved. Currently getting my PhD in applied physics and high energy and nuclear. Where did you attend? I'm not telling you. How do you refute the fine-tuning argument? That's a debate topic that I'm not going to get into today. Can you fuse iron, or does it take too much energy for the star? You can fuse iron. You can add stuff to iron. The point is it takes energy to do that. It doesn't release energy. Is the vacuum empty? Depends on what you mean by empty. What makes proton positive and electrons negative? Is there a significance of positive and negative? It's just a convention. That's all it is. Why does the strong force behave differently from other forces? Other forces just decrease its distance, but it increases. So look, there's kind of two things happening. There's the strong nuclear force, which is no, go away. There's the strong nuclear force, which is what keeps protons and neutrons together. That decreases with distance. It's because it's mediated by a pion, which has a fairly high mass, and so forces mediated by particles with mass, those have short range. On the other hand, there's quantum chromodynamics, which is kind of like the color force, if you will. And that's what the strong nuclear force comes from. Now that is very strong. It's so strong that it increases with distance. And why it's that way? It's a different kind of force. It's called essentially the reason why it's that way is because it's the relevant force field. So for electromagnetism, you have the electromagnetic field. The gluon field, which is the relevant force field for quantum chromodynamics, for the color force, is called non-abelian, which means that the electro or the gluon field itself or interacts with itself. The electromagnetic field does not interact with itself. It's abelian. But because the gluon field interacts with itself, this causes the very, very strange behavior. It's called confinement. And so you end up with a very, very strong force as a result. Seems like positive electron would have been a more natural convention. Yeah, plausibly. Does the concept of only measuring two-way speed of light ever actually affect your work? No. No, it doesn't. It doesn't affect anything. What is electron spin? Electron spin is like if the electron was spinning, except it's not spinning. No, it's a terrible answer. Electron spin is an intrinsic property of an electron. So electrons have mass intrinsically. That's just like a thing that electrons have. They have charge intrinsically. They have something called weak isospin. I guess it's not isospin. I guess it's, well, they have weak hypercharge anyway. And they also have angular momentum. That's just a part of being an electron, is having some amount of angular momentum. And we call that angular momentum spin. Can people working in R&D in a company still contribute to physics in a meaningful way? Yeah, sure. It'll be more applied stuff generally, but yeah, definitely. Are you a role-playing gamer? I haven't played any TTRPGs in a few months, but yeah, generally. Do you know anything about detecting neutrinos using xenon? I don't, not offhand. How long we have left with climate change? Humanity is not going to go extinct, probably. But things are just going to get worse, right? And we don't want things to get worse. What's the difference between a cup of coffee and a particle? A cup of coffee is made of many particles. That's the difference. Is space physical? I mean, in some sense. If angular momentum is directly proportional to mv, omega, and r, why isn't there product? What? I don't know what that question means. Is the electron always spinning? It always has angular momentum. You can't take away the angular momentum from an electron, but it's not spinning. How does the Higgs field work? So the Higgs field is, so to be clear, I just want to back up a little bit. A field is a rule. It's a mathematical rule. You plug in a position and a time, and it spits out a number, or perhaps multiple numbers. So in that way, it's like a function. Like if you have a graph, you spit it, it takes in an x value, it spits out a y value. Well, a field takes in an x, y, z, and t value for x, y, z position and t for time. So the Higgs field is that kind of thing. It's a mathematical object, and perhaps it has ontological status. It's a mathematical object that takes in a certain value and it spits out a number. In this case, it spits out a complex number with weak isospin, or with weak hypercharge, weak isospin. But it basically spits out a number. Now, one of the features of this number is that it happens to be that if you were to take the average value of this number across space, you measure it everywhere, you get something that's not zero. And what that means, it has something called a vacuum expectation value. And the reason why this is important is because it's precisely that thing that gives rise to mass. Basically, because it's not zero, because it's some non-zero number, other things interacting with that field feel that non-zero amount of energy that the system has. And so that slows them down and they behave like they have mass. Grimlock with the $5. Can an electrochemical signature ever imprint on a part of the electromagnetic field? An electrochemical signature? I don't know what that question means. But thank you for the $5, Grimlock. So the electromagnetic field, there is something called electromagnetic memory, which is only recently being discussed. There was a paper by Leonard Susskind like 10 years ago about it. It's called the memory effect. But I don't think that electrochemical stuff is doing that. But I'd have to get more details. I know you're more on the theory side, but how do particle detectors work? So there's a few different ways that particle detectors can work. One way is that you have a substance. You design a substance, like you have some crystal or some plastic or something like this. And one of the properties of that substance is that when a particle of a certain amount of energy passes through it, there's a bright light, like it just flashes when that particle hits like an atom or something like that. And then you can detect that. you can detect that light, and then based off of, the properties of that light, where it is, what direction it is, and all of these things, you can measure the particles. There's also things where you can essentially you can directly detect electrons, because electrons are charged particles. So you can basically detect the electric field as they're flying through space, the electric field that kind of trails them. So if you have electrons and you want to detect those, you can basically put wires around them, and those wires can then kind of detect the changing electromagnetic field. So there are two ways that you can do it. Oops. Sorry, I gotta... There we go. Any tips to memorize long, complicated derivations? Just do them over and over again. Like, honestly. What is the field of physics you're currently working on? So right now, I'm probably going to be starting some projects on like doing some quantum gravity stuff for Hawking radiation. So I generally do relativity and things related. Oh, now I'm see-through. I don't like being see-through. I generally do relativity things, and I, touch on quantum gravity stuff. So it's those things primarily. Sorry, I have to sneeze. And anyway, are weakly interacting massive particles still the most possible potential candidate for dark matter? There are people still actively looking for it, but there are also things like sterile neutrinos and axions that people are looking for as well. Yeah, guys, if you like what you're seeing, consider joining the Discord. There's a Discord server where I am, and I send out announcements there all the time for everything. So go join that. How many dimensions are there? At least 4. 3 of space, 1 of time. Can you explain how mass increases when speed increases? Mass doesn't increase when speed increases. What happens is that momentum increases when speed increases, and momentum increases non-linearly. But that just means that momentum is not equal to mass times speed, except at very, very low speeds. From Nyavakat with the $5, thank you so much. Do you think quantum mechanics supports or contradicts free will? Also, is consciousness an energy? If so, can it not be created or destroyed as well? So quantum mechanics doesn't really say anything about free will. Whether quantum mechanics is deterministic or whether it is stochastic or statistical random, neither of those really leave the option for free will being involved. So no, physics in general doesn't support free will, because the way that we approach physics is that things are either going to be random, in which case there's no free will, or they're determined by the previous conditions, in which case there's no free will. Also, is consciousness an energy? Consciousness is not an energy. Energy isn't a thing. Energy is like a property of a thing. So you can have like, we can talk about like a hot pot of water has a lot of energy, but energy isn't a substance that pot of water is containing, right? Consciousness, on the other hand, that's a question for a neuroscientist or a neurobiologist or a psychologist or something. Not a question for me. But yeah, suffice it to say, it's fairly evident that consciousness absolutely ends when a person's life ends. Can you briefly explain how time travel really works? Well, we're doing it right now. We're traveling forward in time. The faster you travel through space, the slower you travel through time. So you end up kind of time traveling to the future. How do you find a subject for a project? Curiosity or trying to solve and question? It could be both. Within general relativity, how do the 4 fundamental forces interact with affect each other? I don't really know what the question means. So we don't have a theory of quantum gravity, so we don't know how to talk about gravity at a quantum level. But you can do quantum field theory in curved spacetimes, and then you can even invoke kind of quantum averages as being the source of matter, the source of energy, the source of momentum, and so on. For spacetime, this is something that's called semi-classical gravity, and it's just generally hard. But otherwise, it's not particularly like... there's nothing like particularly like mind-bending about it. And by the way, thank you for the galaxy in my book. I appreciate you. Genuinely. From Fear's interaction with the $10, excluding meteorites, comets crashing into it, what, in your estimation, is the greatest external threat to life on Earth? Gamma ray bursts, probably. Yeah, so it turns out that if a gamma ray burst went off near Earth and pointed at Earth, because they're directional, typically, it would just sterilize the planet. Like, the whole planet would get a terrible, terrible sunburn. Like, the planet would be sterilized. That'd be pretty bad, but also very, very rare. Is the are the messages not popping up the way they should? Let me try something really quick. Um, so it's set both to visible, but it's not changing the text. Weird. Okay. Anyway, have you met a religious physicist? Yeah, I know a few. Well, I know one, and he's on TikTok, and he's really annoying too. No, generally we don't talk about our like religion or stuff. It sometimes comes up like, at conference dinners when people are a little bit loosey-goosey, if you will. Um, can you explain the Copenhagen interpretation? Yeah, so I explained it earlier, but the Copenhagen interpretation is basically just we have a quantum system, and when you measure it, for reasons unknown to us, the wave function collapses into one of the measurements, or into one of the eigenstates associated with the thing that you're trying to measure. That's it. It says nothing about the potential mechanism. It doesn't explain what a measurement is. It just says, look, this is just the thing that happens. What causes gamma ray bursts? I made a video about that a while ago. I don't remember off the top of my head, but I can refresh my memory really quick. I think one of the ideas is neutron star collisions. Yeah, but go watch my video. I talk about it in more detail there rather than wasting time here. I sent you a screenshot of what's happening with your super chats on YouTube. Oh, you did? A screenshot? Yeah, that's really weird. I'll need to fix that. Do you think a warp drive is impossible? Basically, yeah. It seems like that's impossible, definitely. Thank you for the galaxy shart attack. That's funny. Let me try something really quick. I have a potential solution, so I'm just trying it really quick to fix the super chat stuff because I don't want people's messages not being seen. All right, test. Oh, that didn't work at all. That didn't work in the slightest. That's not working at all. Um, huh. I don't know why that's the case, but okay. Anyway, we'll just go back to answering questions. Oh, I missed a few. From Kyle McDonald with the $10. Thank you. Thank you so much. Wrote a sci-fi book, but in my universe, they have a jump gate that creates an artificial wormhole to other gates in the network. How can I ground this so it's not magic? Basically, you'll need to invoke something called something like you can call it like negative matter or exotic matter. This would be matter that has negative mass to stabilize the wormhole. That's really what you would want to do. Oh, wait a minute. I think I got it. I think I figured it out. And I also lost the um I also lost this for some reason. But okay, I think I figured it out. Let me just test this. Much better. That wasn't a real super chat, but anyway, we're back. We're back. I know what went wrong. Right. Do you think negative matter exists? I suspect not, because if it did, then the universe would break. Who's better at math, physicists or mathematicians? Physicists tend to have really good intuition, really interesting insights, but mathematicians are obviously better. How to understand topology? Take a topology class. Photons have no mass. I mean, that's cheeky, but look, topology is a complicated subject. It's more than just shapes. So there's a lot to learn there. Photons have no mass, then how is gravitational lensing possible? Gravitational lensing happens as a result of space-time curvature being introduced, as a result of space-time bending. And so the light has to travel through that space-time, so the light is going to be affected by that warping of space-time. Thoughts on Osterwald-Schrader reconstruction theorem? I haven't heard about it. I'm not familiar with it. Why do gingers exist? No, I don't know, but we don't want to get rid of them. Mike Rappy, what do you think about Brian Cox? Generally very, very good, I think. I think he does a good job. Would negative energy be possible if our universe isn't on the global minimum? What would happen if it existed? Would it collapse into the universe? It's not that it's not negative energy that's the problem. It's you need negative mass. At least that's like kind of one of the expectations. And what that means is that you have something that has negative gravitational mass. And if the equivalence principle holds, then it would have negative inertial mass too. And what that would mean is that if you pull on it, it would push. And so from the gravitational effects of it, is that it would just fly away from something that it itself is attracting. It would be all sorts of messy. It just but you basically have stuff like approaching the speed of light forever, getting arbitrary, like it would be a real problem. Do you think you can provide a help towards people who are trying to solve the Riemann hypothesis? No, that's not my field. I don't do analytic number theory. How hard uncommon is it for an engineering major to go to physics grad school? What would you recommend? I've never seen it happen, but that's not to say that it never happens. You're just missing a lot of physics if you do that. But I guess it depends on the kind of physics that you want to go to grad school for. Who's your favorite physicist other than yourself? Living, it's probably got to be Roger Penrose. Dead, it's got to be Albert Einstein because he's the GOAT. What actually is time and why does it seem to only move forward? Well, it depends on kind of like how far you zoom in. So it could be that time is emergent, that it's just kind of like this macroscopic emergent thing that arises from some microscopic quantum stuff that doesn't have time. In the same way that like, something being wet isn't a thing that exists fundamentally, it's just a result from water molecules existing. But if you zoom out, time is a one-dimensional part of the four-dimensional space-time. And the reason why you can't turn around in time is because it's only one-dimensional. If you wanted to turn around, like we can turn around in three-dimensional space because there's three dimensions to make the turn in. In one-dimensional time, there's only one dimension. You can't turn around in it. Now, why it goes one direction rather than the other? I suspect it's because it's the direction that it goes in. That's the direction we call forward. What's your favorite physics equation? It's got to be the Einstein field equations. They're just so nice. They're also horrible, but they're also really nice. White holes almost certainly don't exist, no. Otherwise, we'd see them. What's your advice for an incoming first-year STEM PhD student? Find a PhD advisor that you like personally that you like. What do you think about the Fermi paradox? I think it's pretty easily solved by just recognizing that the universe is big and it's hard to go, it's impossible to go faster than the speed of light. What is the specific challenge of quantum gravity? It's because the gravitational field is not normalizable or something else? It's because the gravitational field is non-renormalizable. That is a mathematical and technical issue to overcome. But there's also a whole bunch of other issues. Like the way that we do quantum field theory typically relies on, kind of like an extrinsic background or like an external background on which the quantum field lives. But if the background itself is the thing doing the changing, it's not super clear what that even means. So there's some serious conceptual issues too. Is the universe inside infinite numbers of black holes? We don't really have any evidence that supports that, no. And by evidence, what I mean is we don't have any hypotheses that have made good predictions about the world around us that rely on the black hole universe. If matter is just a localized stable wave, no particle-wave duality, just condensed energy, what conflicts arise with current physics? Well, I wouldn't say it's condensed energy. I would just say it's a wave. I don't know if I would say a wave is energy. But I don't know what you mean by what conflicts arise with current physics. Is there real evidence of other dimensions? No. Do smaller beings with less gravitational pull perceive time faster and slower due to space-time bend? Very, very mildly, I guess. So currently we are like on the surface of Earth. Our clock is ticking ever so slightly slower than the clock of somebody who is very, very far away from Earth. The closer you are to Earth, the closer you are to a big mass, the slower your time, the slower your clock ticks. So if you were a small being, if you were a super small being, then near a super small planet, then it may very well be the case that, sorry, let me make this a little bit smaller. Then you would experience time slightly faster, but not really in any significant way is the important point. Because we already experience time basically as fast as you can. From John Jackson with the $5. Have you ever heard of Le Chatelier's principle? And should it be applied when modeling the environment? I've never heard of that, but we can Google. Le Chatelier principle. Let's find out. It's a principle used to predict the effect of a change in conditions on chemical equilibrium. I have never heard of this. Should it be applied when modeling the environment? I don't know. I've never heard of it. I'd have to think about it some and read more about it. Do you think the universe is fundamentally continuous or discrete? I don't know. I kind of flip-flop on it. Can you explain the thing about there being 11 dimensions in quantum scales? Well, look, so one of the suppositions of string theory is that if string theory is true, then there are 6 extra spatial dimensions that are curled up really, really small so that we don't notice them. But they're still there, and if you were small enough, then you can move around them. We're just too big. From Rob, thank you for the $2 Cash App. Yes, I also have ADHDs. Passion versus IQ for getting PhD in physics. I want to start, but I'm scared I'm not smart enough. The only thing that you can do is try. And if you don't succeed on the PhD, you can at least masters out. Are there really particles that live time slower than us? I think I read that sometime back. I don't know what that question means, but yeah, if a particle is going very, very fast with respect to us, its clock will appear to move slower. Starting my PhD in physics soon, what's your biggest advice? Find an advisor that you click with personally, because you're going to be spending a lot of time with that person. You want to make sure that you're not miserable. What university did you attend and did you go to grad school? Well, yes, I have a PhD in physics, but I'm not going to tell you where I went. Is the universe inside a black hole? I suspect not. Does your research pay well? Research generally does not pay well, no. It doesn't, it's not, you're not making big bucks from research. In fact, when you publish a paper, you don't get paid for it. Hello, can you please talk about or explain the Planck length and Planck time? So these are just units. These are just like you have a meter, right? You have like an hour. These are like ways of quantifying distances and times. The Planck units, Planck time, Planck length, Planck volume, Planck energy, these are just units. These are just equally good units. So the Planck length is a particularly short distance. It's like 10 to the minus 35 meters or something like this. Yeah, it's about 10 to the minus 35 meters. And so it's a convenient unit when you're studying anything that has to do with both gravity and quantum mechanics. That's how the Planck length was kind of defined. It was defined using the gravitational constant and Planck's constant, which is the kind of the quantum mechanical constant, and a few other things, the speed of light. And you can figure out a distance by combining those constants in a particular way. Similarly, the Planck time is like 10 to the minus 44 seconds or something like this. And it is also combined by combining different units to get the right thing, to get the right set of units. It's just a way of, it's just a particularly convenient set of units for describing you know, quantum gravity stuff. What is the specific challenge of quantum? Oh, I already answered that question. Can you explain Noether's math about symmetry and why there is no conservation of energy? I'm working on a long form video about that, so keep your eyes open, but it's hard to explain math in this setting. Essentially, it just follows from from doing variations with respect to symmetries. But it gets a little bit more complicated than that. From Flight RN with the $5, thank you, as always. If we subscribe to the Big Bang Theory and the universe is expanding, what is it expanding into? What is at the edge of the universe? So, common misconception, the Big Bang is not expanding as in it's not like its edges are getting further away. As far as we can tell, the universe doesn't have edges. Expansion is a local thing, meaning that ignoring what's happening anywhere else in the universe, if you go to some empty patch of space, and you put a cube, if you make a cube out of ping pong balls, you don't join the edges, you just put them in space, and then you wait 10 billion years, that cube will be twice or will be 8 times as big. If the initial size, if the initial side length is 1 meter by 1 meter by 1 meter, then in 10 billion years, it will be 2 meters by 2 meters by 2 meters. It has absolutely nothing to do with the edges of space moving or anything like this. It is a purely local phenomenon. It happens in the space itself. The way that distances are defined is changing. If they're glued together, then they won't expand. How do you know this? Have you been there? We can see the space expanding, right, with telescopes. That's the whole business. Why do mediums slow down photons? In theory, is there a substance which doesn't slow light down? Well, yeah, like the vacuum doesn't slow light down. The reason why mediums slow photons down is because they're not photons anymore. They become quasi-particles, or, like electromagnetic electron photon. The electrons and the photons kind of become coupled together, or rather the electrons and the phonons kind of become coupled together. And essentially, so pure photons just don't exist in a medium, is the point. They're just, they just don't exist. It's something more complicated when there's matter involved. Is the center therefore everywhere? Yes, the center is everywhere. This dude goes into zero detail. Well, what, you want me to do mathematics? I don't have a blackboard. I've just finished my Bachelor's of Science in Astrophysics. What industry type jobs would you recommend? Oh, I wouldn't. Not that I don't think that you should go into industry. I just don't know any. Yeah, polaritons. There you go. Are there any conspiracy theories you believe? Not really. So when I say local, what I mean is it's the thing that happens within space. It's like an intrinsic thing, rather than a thing happening at the edges. Do you consider reality as a high-dimensional Hilbert space? Sometimes, depends on my mood. What is antimatter and dark matter? These are two separate things. So antimatter is like regular matter, except all of the charges are flipped. And it's not just electric charge that's flipped. It's also color charge, it's weak hypercharge, it's weak isospin. These are all the different charges associated with the different forces. Antimatter takes everything about the particle except its mass, and it flips the sign. So if it did have green color charge and positive, and it had positive electric charge, then it would have anti-green color. Then the antiparticle version would have anti-green color charge and negative electric charge. And dark matter is completely unrelated. It is a hypothesized type of matter that just doesn't interact with light at all. It doesn't have any charge, and so we can't see it, because the only things that we can see are things that have charge, or things that interact with things that have charge. Are mathematicians on the way to become obsolete in the next 10 years? I suspect not. A lot of mathematics is very disjoint and not very systematizable, and AI kind of requires systematization. But who knows? Comments on your boy Eric Weinstein? I think that he's a hack. What do hypercharge and isospin mean? These are just different ways of these are the quantities that the weak nuclear force cares about, basically. So there's weak hypercharge. Let me make sure that I get this right, because there's weak isospin, weak hypercharge, or there's weak God, there's so many of these quantum numbers. So there's hypercharge, there's weak hypercharge, there's isospin, and there's electric charge. And these four things are all related to each other. And it's just kind of a different way. So the reason why there's all these different things is because the electromagnetic force and the weak nuclear force are actually two different sides of the same coin. Something called the electroweak force, if you will. And so when we're talking about the electroweak force, what we really want to talk about is a different set of types of charges. When we talk about the electromagnetic force and the weak nuclear force, we change the name to refer to the charges that those things refer to. So so we use, so the generators of the electroweak force are weak isospin and weak hypercharge. And a combination of those, it turns out, you get weak hypercharge from one combination of those, and you get regular charge from another combination of those. It's very weird. The physics of the standard model is very weird, especially of the weak nuclear force. We often see physics in perspective of mathematics. Is there any other perspective we can view physics? Maybe, but that's not really the way that we do physics nowadays. What's the definition of quantum gravity? Quantum gravity is like the concept that refers to any theory that purports to describe gravity at a quantum scale. There's no outer space. The rainbow demonstrates the physical barrier above the Earth. Rainbows are purely optical phenomena, which is why they move when you move. And they always occur at the exact same angle. So if there was actually a dome over us, the angle would depend, like the angle and hence the height would depend on where, like what your latitude is, but it doesn't. Is vacuum energy created as space expands or does it spread out? Yes, in principle, that is the case. Do you think we'll ever know all of physics? I suspect not. Wait, are you saying when you say that it's color flipped, are you saying that it absorbs light? No. So color, when I refer to color, with refer to the color force, this has nothing to do with light. This has nothing to do with color that your eyes see. It's just a name that physicists came up with to describe the types of charges, the types of the types of interactions of the strong, or of the what causes the strong nuclear force. So we say that there are 3 different types of charges for the strong nuclear force. There's red, green, and blue, and then each of those have their opposite: anti-red, anti-green, and anti-blue. And so if you want to get to neutral color charge, you either add red, green, and blue together, or you take red and anti-red together. How can an electron have intrinsic angular momentum if it's a point charge? If it's not a point, what are its size and shape? What intrinsic means is that it's not a result of a thing spinning. If it were a result of a thing spinning, then it would not be intrinsic. It would be extrinsic angular momentum, or orbital angular momentum, if you will. Or because you'd have something spinning about an axis, orbiting it, if you will. On the other hand, because it's intrinsic, it doesn't require any actual motion. If acceleration is slowing, does that mean dark energy isn't just vacuum energy alone? Yes. If that's the case, if dark energy is truly dynamic, then dark energy is just not the vacuum energy. It's just not, because the vacuum energy is constant. That's like the whole business. And so that blows the whole fine-tuning of the cosmological constant completely out of the water. It just completely resets the problem. What was your PhD about? My PhD was on conformal geometry. It has some applications to the ADS-CFT correspondence. Does quantum entanglement state that there is no real randomness in the nature universe? No, it doesn't state that. Quantum entanglement is just about correlations between otherwise seemingly distant particles. There's a correlation in their quantum states. I bet entanglement is the dominant mechanism below the Planck scale, materiality's basic structure. Maybe. What's up with the alcohol cloud in outer space, and what color are clouds in space? So most clouds in space are so sparse that you can't see them. They're just like it's more like a collection of gas in a particular place that's like kind of denser than the rest of the universe typically is. These are not clouds that you can see typically with the naked eye. But alcohol is a fairly simple chemical, and so it's totally plausible that you could just have a cloud of that chemical hanging out somewhere. Does being a physicist mean you have a day job, or do you work as a scientist professor? So so it's summer, so I'm not currently working at a university. I'm not currently teaching. But being a day job, being a physicist, typically that means that that's your occupation. That's what you do. At least that's the way that I think about it. The way that you spend a lot of your time is working on like doing physics research. Now, being a physicist sometimes includes also being a teacher, like teaching at a university or teaching on TikTok like I'm doing now. But that's not like the core part of being a physicist. So when I say I'm a physicist, what it means is that I spend 5 to 6 hours every day working on research problems, submitting papers, etc. Both in mathematics and in physics. That's my area. Is Veritasium trustworthy? I used to like Veritasium a lot. They've had a few issues. I think that generally they're still quite good though. Oh days, this isn't another Pirate Software type of guy. I don't know who that is. Who is Pirate Software? Why is friction considered a non-conservative force in terms of time reversal symmetry? Explain how this relates to the second law. That sounds like a quiz question. I'm not going to answer that. That sounds like a question for a test. Is that like drinkable alcohol or isopropyl alcohol? I don't know. It depends on the cloud, right? Is reality truly probabilistic, or are we missing something deeper? We don't know. We really don't know. What's your favorite element and why? I like technetium because even though it's very light, it's very, very hard to, like, it's purely synthetic. Like, we don't find any really naturally occurring, except, like, very, very occasionally. Have you ever owned a pocket protector for your pens? No, I just used to keep them in my literal pocket, not my shirt pocket, but no, I have never owned a pocket protector. Explain thermodynamics laws with a day-to-day example. Yeah, so there are 3 laws of thermodynamics. The first is energy conservation. One way to think about this law is that the higher up you want to lift a bucket of water, the more energy you have to expend. Pretty straightforward. The second law of thermodynamics is that the entropy of a system never decreases, the entropy of a closed system. This essentially explains why. So if you view entropy as disorder, then it kind of explains that why when you drop an egg, it'll crack, but an egg will never jump to the top of a counter and then uncrack, like reform, because one of those configurations has a higher entropy than the other. So the system will always evolve towards the state with the highest entropy. The third law of thermodynamics is that you can never reach absolute zero. This is not really easy to explain via everyday examples, but the best way to think about it is that the colder something gets, the harder it gets to make it even colder. Because in order to make something colder, you kind of have to put it next to something even colder than it. And there are some ways to do that, but it's hard. That one's pretty hard to explain with everyday examples. Who are your favorite, most trusted internet science communicators? Hank Green, very trustworthy. Matthew O'Dowd with PBS Spacetime, amazingly trustworthy, very, very good physicist. A lot of my mutuals are excellent. In fact, I would only be mutuals with somebody if I think they're excellent. So like Ibrahim with Blackbird Fizz, Alvaro with Math and Cobb, Abby with Pop Culture Scientist, Skylar with Skylar's Space Facts with Skylar. There are a lot. Event Horizon is also really good. Evan, who is also known as Event Horizon here, really, really good on TikTok. I don't really. Dakota. That's right, Dr. Dakota Starkid. Excellent job. He's super good. So yeah, I mean, like, I could just list names. Why can't we put a patent in front of a car so the car can drive endlessly? What? A magnet in front of a car. Oh, the magnet will pull on the car, but the car will pull back on the magnet. Overall, the net pull will be 0. Neil deGrasse Tyson does a good job of getting people excited, but sometimes the way that he says things are misleading. Is it because I donated enough? What? Is what because you donated enough? I'm confused. What did you ask? Oh. Do you know Professor Dave? I don't know him personally, but I think we're mutuals. No, it's just, well, okay, so it probably started because you donated enough, but I started following you after you made the chair video. I think that's when I started following you, and I thought that was really, really funny. And also, you've been part of my community for like eons, and you're a mod, so you know it. I'm mutuals with like mods and stuff, and like people who have been around for a while. Gutsick Gibbon is also good. I just don't watch a lot of her stuff because it's mostly anthropology stuff or, human biology stuff, and that's not my field. Do all physicists wear glasses? A lot of us do. Yep, a lot of us do. You said clouds can be alcoholic. Yeah, so these are like alcohols in space, alcohol clouds, and it's not like some result coming from fermentation. It's just like that is a chemical that can form naturally, like ethanol, methanol, isopropyl, or isopropanol. These are chemicals that can form like via natural processes, and so sometimes you end up with clouds of them. Copenhagen or many worlds? I prefer many worlds. Are you really a physicist because there are 4 laws of thermodynamics? So are you mentioning the 0th law of thermodynamics? The 0th law of thermodynamics is not really a law. It just states that there exists absolute 0. That's all the 0th law of thermodynamics is. But it's more of like a definition than it is a law. What's my thesis in? So my thesis was on conformal geometry, which has applications to the ADS-CFT correspondence. Do you know anything about somatics? I'm going to start studying it for my gemstone designs. I do. Somatics are not like some mysterious thing. It's just, I actually have a pretty detailed video about how they work from a while ago. They're basically just resonant wave patterns. They're not quite waves, but they're resonant wave patterns on solids. Can you explain the devil's staircase mathematics? I'm not familiar with it, so probably... Well, let me pull it up. I may have heard of it by a different name, and so let me... Oh, are you referring to the Cantor function? Yeah, it's just a really weird function, but like I don't know what else there is to explain. Like the way that you define it is what you split the segment up into thirds, and then you keep the middle third fixed, and then you take the other 2/3 and you split those up into thirds, and you keep their middles fixed, and you you associate their x value with the y. Like it's like a weird thing. But it's not anyway. What kind of hobbies do you have outside of your work? I play video games mostly. And I watch Star Trek a lot. Was Tesla a hack? Kinda. Do you play KSP? I did a long time ago. I haven't played it in a long time. What's the meaning of life and everything? I don't know. Hey, Blitz, do you have a day job or is content creation your full-time gig? So, applications are openings for like postdocs in physics or postdocs in mathematics and physics and professorships and things like this. Applications are slowly opening for the next cycle. So I am currently applying for those, but depending on if I get any of those or which ones I get, I might just do content creation full-time because it pays better than a postdoc. And if I have to teach for any of these postdoc positions, that will lead up more time than content creation does. So just all things considered, I would be able to do more research if I do content creation full time, depending on what type of job I get. Now, if I get offered a tenure track job, then absolutely I would take that 100%, and my content creation would have to slow down. But for now, content creation is my full-time summer gig. We'll see what happens in fall and winter when jobs start opening up. How do you get into physics research academia? You go to grad school for physics, basically. What games do you play now? I've been playing a lot of Overwatch. The stadium game mode's really fun. I have a meeting in half an hour. Don't let me forget. I can't answer that question. Is your job theoretical or practical? I'm a theorist, so I do mathematical physics. Thoughts on gravastars? I think I just reposted a video where I made a video about that. What would be your field of study if not physics? Mathematics. With $2 from Mitchell Manley, thank you. Best episode of Star Trek Next Generation. The Measure of a Man is really, really good. Like, it's so good. I'm trying to think which other episodes are my favorite of TNG. That might be my favorite. It's such a good... I'm sure that there are others I'm missing, but that one's just excellent. What's the first one where Lucretia shows up? Maybe that one too. John Tolan with the $2. Thank you for the gift. The Inner Light's really good, but like I think I'm not old enough for that one yet. Best of Both Worlds. Yeah, there you go. That's what it's called. Overwatch mentioned who do you play? I'm a Mei main. How do you explain a finite limit of energy in the universe? I don't know what you mean by a finite limit. Ever seen Spartacus? I saw the TV show, yeah. Why'd you choose to be a physicist? Because black holes were cool. What is string theory? String theory is a mathematical model that purports to describe quantum gravity. Now, it doesn't describe quantum gravity in our universe because it requires supersymmetry, and our universe doesn't seem to have supersymmetry. But there is like a world that you can conceptualize where string theory does describe that world. And so we can learn about quantum gravity in our universe from thinking about quantum gravity in that universe, in that world. Who's your favorite Star Trek TNG character and why is it Data? It's not Data, it's Spot. Get your answer right. Is your work environment competitive? Under the surface, it's very... Oh, no, no, you know what? Darmok might be my favorite. Or it's up there in my top 5 at least. Darmok's excellent. The thing about being an academic is that there's a certain sense in which there's competitiveness under the surface. Very, like, really competitive under the surface. meaning that you have a whole bunch of people who are applying for the same jobs, and even though they're all very friendly and all very willing to collaborate, we know that we're competition with each other. On the other hand, I've never had a bad experience. Well, I've had one bad experience, but that was with somebody I didn't know. I've never really had a bad experience with like people like stealing work or people like refusing to collaborate because they want to publish first or whatever. I've had very good experiences with collaborations and so on. Can you explain what a field is? Yeah, so a field is just a mathematical function that takes as input positions and times and outputs something. So you can think of it like a graph where the inputs to the graph are x, y, z position and t for time. And that's basically it. You claimed there's a finite limit of energy in the universe? Oh, in the observable universe, absolutely. But not in the universe as a whole. If the universe is infinitely large, then there would be an infinite amount of energy in it, of course. How does nothing turn into anything? I don't know. I don't know why anyone would ever suspect that. Are electric field and magnetic fields different things? They're two sides of the same coin. Ain't you the guy that reported his entire class for cheating? No, you must be confusing me for somebody else who did that. I caught like 20% of my class cheating and then gave most of them a letter grade because a letter grade dock. So I docked them from like an A to a B or a B to a C. And then a few of them did it again and they got failed. So like 10 of them got failed. So yeah, I'm not the guy who reported the entire class for cheating, no. Must be thinking of somebody else. Is there any reason to worry about the Earth suddenly spinning faster? No. What do you think? Is the universe infinite? Seems plausible, yeah. If the universe had a shape, which shape do you think it would be? It would be like a three-dimensional sphere rather than a two-dimensional typical sphere. The typical sphere, when I talk about a sphere, I'm talking about the surface. So the surface of a ball is the surface of a three-dimensional ball is a two-dimensional sphere. So the surface of a four-dimensional ball would be a three-dimensional sphere. So if our universe has a shape, it would probably be that one. Are you actively following any degree? I have 4 degrees. I'm done with my degrees. What physicist from the 21st century had the greatest impact on the field? So Sabrina Pasterski has a lot of impact right now. Her celestial holography business has been really, really influential, at least in like fundamental physics stuff. Yeah, I'd have to think some more about that. Can you do a video on a paper? I do videos on papers occasionally, ones that are interesting to me. Will Vera Rubin find Planet 9? If Planet 9 exists, maybe it will. I've learned Newtonian mechanics in high school. Is it worth learning Lagrangian mechanics for quantum mechanics? Absolutely, yes, absolutely. Hawking's most important work was not in the 21st century. That's why I didn't include him. Is the 5D from Interstellar accurate or inaccurate? The end 15 minutes of 5D or of Interstellar is just not that great. The last 15 minutes. It's just like the physics isn't great. The rest of it's very, very good though. Can you debate Bob Lazar? He's a hack and I'm sure he would never debate me. Question trans rights? Trans rights, of course. How accurate are the things that young Sheldon talks about? Usually pretty good. Gravity is measurable and has waves, right? Can it theoretically have polarity? So the gravitational waves do have a polarization. There's the plus polarization and the cross polarization. And it's basically just, you have polarization that looks like this. So you have contraction that way, and then you rotate the whole thing by 45 degrees, and it looks like this. Those are the 2 different polarizations that gravitational waves have. Thoughts on curly hair on men? I mean, I have pretty curly hair, generally. It's kind of wet right now, so it's not very curly, but yeah. What are all the ways to curve spacetime? Anything that has energy, momentum, pressure, or stress, those things all contribute to spacetime curvature. If you can prove light is not a wave and you can prove light is not a photon, then what is it? Light is a wave. Photons are waves. Photons are wave packets in particular. Why is it that with the photoelectric effect, calculations show a really long time for emission of a... You'll have to finish that thought. Have you looked into Scientology? Is it based on science? It's not based on science. Thoughts on Eric Weinstein and the theory of everything? He's a hack. Cookie Bennett with the 5 Canuck bucks. I wish I got talked by you in college. Also, what country do you work in? Is there a reason you work there? Well, I appreciate that, Cookie. My students generally really liked me, so you wouldn't be alone. What country do you work in? Currently, I live in the US, and I'm here because this is where family is. Is there a way to create gravity without increasing mass hypothetically? You can increase momentum, average momentum. All right, Doom Guy with the $2. I'm glad I burped your worm. God, that sounds gross. But thank you for the $2. Is time not just an emergent property, just a quantifier? It might be an emergent property, we just don't know. What course in your academic career spoke to you the most? The general relativity class I took as a senior in undergrad. When the sun is below the horizon, what is the light bouncing off of and still illuminating the Earth? The sky. There's air in the sky, like in the atmosphere above us, and it's bouncing off of the atoms there. Can you explain how we know what our galaxy looks like? That's actually a good question. I haven't thought about it, but I mean, like we can map the position of stars, and I mean, like we're inner galaxies, so we at least get a side profile of what our galaxy looks like. And so we can map, presumably we can map density of stars, and that will be able to tell us like where the stars are based off of how far away they are and so on. Wood cutting level. In RS3, it's 99 plus whatever extra XP I have. Do you think quantum entanglement might be signs of a connection from a higher dimension? I don't think so, no. Do you have a doctorate? I do. I have a PhD in physics. Hello, fellow heathens. I'm on lunch break and thought I would tune into the conversation. Well, welcome. Did you always want to be a physicist? Yes. Basically, since I was like 9 or 8 or something like this, yes. The geometry of relativity turned out to be one of the most impactful classes. Yeah, no, right? It's super important. Can you explain me easily what a tensor is? A tensor is something that transforms like a tensor. Do you teach or do research? Well, currently I'm teaching, and then yes, I also do research. I mean, this is a form of teaching, right? Can any matter be converted to any other matter? In theory, if we have all of the means for conversation, including chemical reagents, nuclear reagents. Not necessarily. For example, you can't turn quarks into leptons. As far as we know, there is not a way to do that. So you can't turn like a proton into an electron. So no, not necessarily. What do you think of Mach's principle, the idea that distant galaxies cause centrifugal forces? Is it falsifiable? So this is actually, it's kind of inbuilt into Einstein's equations, the Einstein field equations. And the phenomenon in relativity is called the lens-Thirring effect. Basically, you have rotation of things far away. That causes the space-time interior to rotate as well. And this causes a sort of centrifugal force. And in fact, this has been experimentally tested, kind of the inverse version, but it's the same phenomenon, has been tested by the gravity probe B. What would happen if you put oobleck in a vacuum? I have no idea. Why are all fundamental interactions local in QFT? I suspect in part it's because QFT is what happens when you take quantum mechanics and you put special relativity into it. And so then, of course, you would expect it to be local because special relativity is a theory about locality, basically. So when you obliterate something like a proton and electrons come out of the particle fields. So the thing is we have something called baryon conservation and lepton conservation. And so there will never be a case where you start with one proton and you end with one or more, and you end with one electron. That will never happen. At least not under the current laws of physics. How did physicists know about atoms before seeing them in a microscope? That's a good question. So they inferred the existence of like pure elements from chemistry, and this was done, I guess, in the 1800s or so. And then from there, it was a matter of kind of like saying, well, you have some sort of pure element, and we know that those pure elements, they seem to come in chunks because you can kind of boil off chunks of them. And then you can do some tests and discover things like an electron. This is what J.J. Thomson won his Nobel Prize for in 1890, or he discovered it in 1897 and won his Nobel Prize a few years later for it, for discovering an electron. And then basically you just start doing experiments that only make sense if atoms exist. Man, I'm hungry. Did I not eat enough breakfast? What does the locality even mean? So locality is roughly this idea that things are only influenced by their immediate neighbors. That's the notion of locality. Consolidated with the $2. If you like Overwatch, check out Straftat. Okay. How often do stars become black holes? And what are some, if any, theories as to where they go? So I don't know the proportion of stars that become black holes, but it's going to be very small because most stars are medium size. Only the biggest stars can collapse into black holes. However, they don't really go anywhere. They stay there. They become the black hole, right? The black holes are just there. They just hang out afterwards. Don't forget my meeting. Yes, I won't forget my meeting. Why do you think we're not in a black hole? Well, the black hole hypothesis just hasn't made any predictions that we've verified, right? Do you consider engineers physicists? No, they're engineers. It's a different thing. Why is my microphone upside down? I don't know. I like it this way. What do I do after my 4-year undergraduate astronomy degree? Well, you could go to grad school if you don't want to go do industry. Should I go into astrophysics or nuclear physics? Nuclear physics probably has more funding, I would imagine, but that's up to you. Angela Collier is really, really good, Denise. She's excellent, but she doesn't put out content very often. I've actually asked her how she does because when you watch her videos, she's clearly not reading off a script because she's not reading off a script. So I just asked how she does that. And she just spends a lot of time thinking about the ideas and talking them out over and over and over again. Do you have any out-of-the-ordinary theories on cosmology, like how the universe actually works? Well, I have some ideas, and I recently uploaded one, and I sent it out for peer review with a very, very high-quality journal. But I'm not going to talk too much about it, because that would dox me if you guys could find it. Oops. Physics or math degrees? Get both. How did NASA be able to get the sound on the Big Bang? I don't know what you mean, but essentially we have data of, like, we can roll the clock back. We have data on what, like, the Big Bang was sort of like, and so I guess you could translate that to sound. What is the physical significance of space-like surfaces of simultaneity, if the speed of causality, light, limits travel of information anyway? So, space-like surfaces, like, you're asking what the physical significance is. Well, like, conceptually, they're what we call the universe, and then we think of them as changing through time. But if you're asking, like, can one thing on a space-like surface influence another thing on a space-like surface? No, of course not. But they're useful for, like, understanding what's going on with the universe. What do you do after grad school if you get an astrophysics degree? Oh. Well, you could go into industry and do big data analysis, or you could go work in academia. If everything is made of atoms, then what is the space between subatomic particles made out of? So not everything is made of atoms. Subatomic particles are not made of atoms. They're subatomic. And space is not made of atoms either. That's not real science you're talking about here. Sure is. Sure is. Is gravity just air pressure? No. Air pressure is caused by gravity, though. If you weren't able to do physics or math, what would be my occupation? Who knows? I'd probably be miserable. What was the hardest class you took? Content level, not just time consuming? Topological quantum field theories. I still don't understand that. Are there mathematical formulas for a black hole? I don't believe so. Yeah, absolutely. The most simple one is called the Schwarzschild metric. Then there's the Kerr metric, the Kerr-Newman metric, the Rossler, or the Reissner-Nordstrom metric. Sorry, I'm like Rossler? Like, but yeah, there absolutely are. Do you read a script for your videos or are you off the cuff? I script all of my videos. What's the difference between a black hole and a white hole? A white hole always has stuff coming out of it. A black hole never has stuff leaving it. Did you ever take linear algebra? Of course I did. Where can I find a better, more detailed description of frame dragging for a non-math guy? Well, you could go to my video on it. I have one or more videos on it. I thought I did a pretty good job explaining it. But it is a math thing, right? So that's how we talk about physics. Oh. Any comments on Veritasium? I love that channel. Perhaps you know the guy. I don't know him. I generally, like, I haven't watched his channel in a while, but I used to like him quite a lot. Which one's out in a great tug of war between the expansion of the universe and the Great Attractor? Oh, the expansion wins. Definitely. What was before the Big Bang? We don't know. We don't even know if there was a before. What's your opinion on the Drake equation? It's just dimensional analysis, so there's not much to say about it. How much a physicist earn? It depends on what, like, it depends on essentially seniority. Why is it not possible to give one equation on all four forces? Well, just because nobody's done it. Do we have the means to artificially bend spacetime as needed? If so, to what degree of accuracy? We do not. Not in any measurable way. Favorite physics concept? Spacetime. Curvature of spacetime. Do you know rocket science? I'm not a rocket scientist, and rocket science nowadays is mostly engineers. I would say that it's definitely not easy. Why does the principle of least action work? Because we made it work, essentially. Will you write my fiance a letter of recommendation? No, because my recommendation probably wouldn't have much weight. How much physics is required for civil engineering? Probably a year or two of classes. What's your opinion on the one electron universe? It's like 70 years out of date. It's not really necessary to explain why all of the electrons are the same anymore. If acceleration keeps slowing down per desi data and Great Attractor grabs those galaxies, what's next? That's a good question. We don't know the answer to it. If a ring was built around the Earth such that the center of gravity intersected Earth's, would it stay floating? If it was orbiting, sure. Alternatively, if it was so rigid that it couldn't collapse, but that would take a lot, that would take very, very rigid materials. Theoretically, can I cook a chicken if I slap it hard enough? Yes. Many worlds or Copenhagen? I prefer many worlds. Does the metallicity of stars have an effect on their lifespan of the star? Yeah, generally. Well, okay. Does it have an effect? Yeah, a bit. But it's more that, like, smaller stars tend to have a higher metallicity, and so they tend to live longer. All right, y'all. I am going to end the live a little bit early because I need to go grab a snack before my meeting. But thank you guys all for being here, for donating, for supporting the live. I appreciate you as always. We will be back tomorrow at the normal time with some debates. So be on the lookout for that. Remember, join my Discord if you haven't already. That's where you can get all of these announcements about when I'm live, when I post a new video, and so on. So again, guys, thanks for being here. Thanks for supporting me, and I'll see you guys next time.